So good evening to everybody. The topic we were discussing yesterday, that was the components of the physical environment. And under that topic yesterday we discussed about the atmosphere, that is the air phenomena, and the various layers of the atmosphere, that is the troposphere, stratosphere, mesosphere and thermosphere, etc. And we tried to discuss it in sufficient detail, which is required for the examination purpose, right? And today we will discuss some other important components of the physical environment, that is the light, precipitation, etc. Right? So let me start today with the light, right? So we are discussing about the light, right? So light is an important component of the physical environment, because without light there would be no life on this planet, right? Can you explain that why light is the necessary you can say element for life, right? Why light is the necessary factor for life on the planet? Why? Can you explain it? Can we survive without light or not? Can there be any life without light or not? Tell me. Do you know? Tell me. I told you that there would be no life without light. Why? Because in the presence of light, plants do photosynthesis, right? So if there would be no light, there would be no photosynthetic activity. And if there is no photosynthesis activity, then obviously there will be no primary production. And if there will be no primary production, then there will be no life on this planet, right? So that is why light is a very, very important component of the physical environment, right? Of the environment, we can say, right? So as far as the light is concerned, what is light? Light is an electromagnetic radiation. Okay. So what is light? Light is basically an electromagnetic radiation, right, which is provided by the sun to us, or provided by the mother nature to us. That is the free of cost, we can say, right? So this is a part of the electromagnetic spectrum, we can say, right? Basically there are the three sections of the electromagnetic, we can say that right, spectrum, light spectrum, we can say. There are three sections of this spectrum, right? So one of the sections of this spectrum, we can say, right, one of the sections of this spectrum, right, we can say, that is the visible light, right? One of the sections in this is this. Visible light, right? And the second section of this electromagnetic spectrum, that is the UV light, ultraviolet light, right? And beyond that, right? And the third important section of the electromagnetic spectrum, that is the infrared light, right? And beyond that, infrared light, right? And beyond that, right? So these are the three sections of the spectrum of light, we can say, right? And out of these three spectrums of light, right, only this part of the spectrum is visible to us, right? Only this part of the spectrum is visible to us, right? And the wavelength of this part of the spectrum, which is visible to us, okay, light is basically electromagnetic radiation, which I have told so far, right? And there are the three parts of the electromagnetic spectrum. One part of the electromagnetic spectrum is the visible light. The other part of the electromagnetic spectrum is the ultraviolet light, light, and the other part of the electromagnetic spectrum, that is the infrared and beyond, right? Okay, so that is the thing, right? So now, as far as the wavelength of this visible light is concerned, right? So its wavelength ranges between 400 to 700 nanometers, right? So its wavelength ranges between 400 to 700 nanometers, right? So that is basically the wavelength, right, of this, you can say, visible light, right? So now the next thing is that, right? So now the next thing is that we can say this visible light, because the if we talk about the wavelength is concerned, right? So the wavelength increases from left to right, right? The wavelength increases from left to right on the electromagnetic spectrum, right? And from left to right, okay. And if I uh, take it otherwise, then we can say the energy of the electromagnetic waves increases from right to left, right? So energy increases from right to left. So these are the important points, right? Right to left. Okay, so this we can say is the wavelength. This we can say is the wavelength, right? And this part we can say is the, that is the energy. This part is known as the energy, right? So these are the two important parts. One is the wavelength and second is the energy, right? So now the point is clear from this only diagram, that we can say that with increase in the wavelength, the energy decreases, right? And with decrease in the wavelength, the energy increases. So that's the point, right? So please bear this in mind. There is an inverse relationship between the wavelength and the strength of the waves, right? So if the wavelength increases, the strength of the waves decreases, and if the wavelength decreases, the strength of the wavelength increases, right? Because the wavelength because the waves with the shorter wavelengths, right, are more energetic as compared to the waves with the you can say longer wavelengths. Okay, so now this is the point, right? So now we were talking about this thing, right, that this is the uh, we were talking about the visible light, right? And the point is important to be noted here that it is the visible light in which the plants do photosynthesis, right? So plants require visible light, right, for the purpose of photosynthesis. So please bear this in mind. This is an important point, right? So plants require visible, right, visible light for the purpose of photosynthesis, right, for the purpose of photosynthesis. So plants require visible light, right? So and that is why this visible spectrum of light, right, or this visible part of the spectrum of light, visible part of the spectrum of light is known as PAR, right? PAR means PAR, right? So PAR means we can say that is the photosynthetically active radiation, right? So in this PAR, right? So P stands for photosynthetically, right? photosynthetically. A stands for active and R stands for the radiation. Okay, so photosynthetically active radiation, so that is there, PAR, right? So this is important, right? Uh, so it is the, we can say that a photosynthetically active radiation is that part of the electromagnetic spectrum, right, in which the organisms do photosynthesis, right? In which the organisms do photosynthesis, in which the organisms produce their food, right? So that part of the electromagnetic spectrum is known as the photosynthetically active radiation, right? Photosynthetically active radiation. Okay. So now the point is that on this side, if we say, right, towards the ultraviolet radiation part, right, so we can say that here comes the first of all, that is the, we can say there is the UV radiation, which is called the ultraviolet radiation in this side. Okay, and then X-rays, right? Let us talk about this part now, this part, right? So this part of the this electromagnetic spectrum, we can say this is further divided into various parts, right? So one part is known as the UV rays, right? UV rays, ultraviolet rays, right? And the second part of this, we can say, right? The second part of this, we can say those are the X-rays, right? X-rays. This is the second part of this, right? And the third part of this, we can say that is the gamma rays, right? The third part of this, we can say that is the gamma rays, right? So now, please bear this in mind, right? So I am making this diagram knowingly because this would be helpful to you to solve a question in your examination, right? Because in such right, in examination, a question can be asked that arrange the, right, arrange the following, right, arrange the following electromagnetic waves. Okay, one second. Arrange the following electromagnetic waves into in the ascending order of, in the ascending order of their wavelength, right? In the ascending order of their wavelength, right? So let us suppose that first is written here, that is the X-rays, right? So second is written here, that is the gamma rays. Okay, and third is written here, that is, we can say, the UV rays, which is called the ultraviolet rays, right? So these three are given here, and below are given the codes, right? One of the codes is let's suppose that is the 1, 2, and 3. All right, 1, 2, and 3, and second code is there, right? Let us suppose that is the, we can say, 2, 1, 3. That is the 2, 1, and 3. Okay, and the third code, which is given here, let's suppose that is 1, 3, and 2, right? And the fourth code, which is given here, let's suppose the examiner has mentioned here none of these, right? None of these. Okay, so now what's there? The in terms of the, right, wavelength, the rays with the shortest wavelength are gamma rays, then X-rays, then UV rays, right? So the correct answer would be 2, 1, and 3, right? 2, 1, and 3. So this is your correct answer, right? So that means we can say that we can say that the ultraviolet rays, or we can say the wavelength of the ultraviolet radiation, right, is more than the X-rays and less than the, that is the visible light, right, less than the visible light or photosynthetically active radiation that can be there, right? Okay, so this is the point here, which is important to be noted, right? And this point needs to be noted here, right? And the next thing is that if we talk about the UV rays only, right, there are the three categories of the UV rays, because these we will study further in the further discussions, right, in the subject. One is the UVC, right? One is that, and the second is we can say that is the UVB, right? And third is we can say that is the UVA, right? So these are the three categories we can say, right? So as far as the wavelength is concerned, right? So here is right. So first, uh, right. So here will come the A, right? So first will be A, B, and C. So this is their order, A, B, and C. All right. So, sorry, C, B, and A will be there. Here will be C, here will be B, and here will be E. Right. So it means ultraviolet C radiation has the shortest wavelength among the A, B, and C, right? Among the ultraviolet A, ultraviolet B, and ultraviolet C radiations, right? So that point is important here. Okay. So now after this, right? So we are discussing about this. We can say about this spectrum. We are discussing about this, right? So now here is right. So on this side, we can say whatever the radiation is there, this radiation can further be divided into three categories, let us suppose. So this is known as the, we can say, infrared light or infrared radiation, right? Infrared waves also. And this part is known as the, we can say, microwaves, right? Microwaves, right? And after the microwaves, right, so the next part which is there, that is, we can say, the radio waves are there, right? So that is the radio waves, right? So please bear this in mind. There is the radio waves now, right? Radio waves now, right? So let me tell you now, it for the purpose of your examination here, right? So we can say that this is the, let's suppose, the spectrum, right? Electromagnetic spectrum, which we are, or light spectrum, we can say it, right? So on this, okay, so on this light spectrum, right? So here comes the, we can say, right? Here comes the gamma rays. After gamma, here is the X-rays. After X-rays, here is the UV rays. After UV rays, this is the visible light. Okay. After visible light, there is the infrared waves. After infrared waves, there are the microwaves, right? Microwaves. And after microwaves, right, there are, we can say, the that is the radio waves, right? That is the radio waves, right? So this is the order, right? So we can say which order. This is the uh, that is the increasing wavelength order, right? Increasing wavelength order, right? Right. And here I told you that this part of the spectrum, right, which is known as the ultraviolet uh, radiation, right? So this is further categorized into three, right? So this part of it is known as the C, ultraviolet C radiation, right? Okay. And this part of it is known as the B, means ultraviolet B radiation, right? B category of waves. Okay. So this is B. Okay. And this part is known as the A, right? This part is known as the A, because such type of questions can be asked there in the examination, that which of the following, right, which of the following ultraviolet rays, right, have the shortest wavelength or has the longest wavelength, right? So this point I think is clear to you, okay? And this is there, right? So now the next thing is that, right, we know, is it clear to everybody, beta? Some important questions can be asked from this part only. If anybody has any doubt, please tell me. Okay, Akshay, clear. Aman, Parveen, Asika, and Amrit, everybody please tell me. Asika is clear. Amrit, is it clear to you?
Got it, sir.
Okay, okay, right. Okay, good. So now the next thing which we are going to discuss, that, right? So now about the light, right? We know that, the main source of light on this planet, that is the sun, right? So sun is the main supplier of light. Sun is the main source of light on this planet, right? So as far as this light is concerned, right? So light, or the availability of light, right? Or the light that reaches the surface, right? Depends on depends on, right? So it depends on a number of things, we can say, right? It depends on a number of things. Number one, what is that? That is the latitude of a place, right? So we will discuss here only some important points we will discuss here, right? So one point is which we are discussing here, that is, we can say, right, that is the latitude. And second important point which I will share with you here, that is the, we can say, season, right? Latitude and season, right? So this is the main thing, right? Latitude and season. So as far as the latitude is concerned, beta, first of all, what are the latitudes, right? So latitudes are some imaginary lines, right, which runs parallel to the equator, right, on the globe, right? Okay. So latitude, let's suppose this is one line, right? So this line is known as the equator, right? And the various lines parallel to this equator, right, northwards or we can say southwards, these lines are known as the latitudes, right? So this is one latitude, this is another latitude, right? There can be many latitudes there, right? And similarly here, oh, this is the one latitude, okay? And now this is the one latitude, right? And now here is the second latitude, we can say, right? So in this way we can say there can be a number of latitudes, right? So these are called the latitudes, right? So now latitude, right? So it means the insolation received on all the latitudes is not the same. Well, right? One thing we can say, insolation. Two important points are there. Insolation received on, right? Insolation received on all latitudes is not the same, right? At a particular point of time, right? At a particular point of time. So one thing is this point, right, should be noted, because right, like it is about 6 now, right, 6 p.m. now, right? So the amount of insolation we are receiving here in Punjab or in India, we can say, right, the same amount of insolation would not be received in, we can say, Indonesia or in Norway, right, or in England or in Australia, right? So at this point of time, the insolation received in Indonesia, Malaysia, Japan, Russia, right, Norway, Canada, UK, or that is we can say the Cuba, Chile, Australia, New Zealand, right, Antarctica, that may not be same, right, which is received in India at this point of time, right? So this is the one point. Insolation received on all latitudes is not the same at a particular point of time. And the second important point, which is important here, right, that we can say, right, insolation on a particular latitude, on a particular latitude does not remain the same, does not remain the same throughout the year. Okay, does not remain the same throughout the year, right? So, like we can say, if we take the case of India, right? So, in the summer season, the northern part of India would be receiving, you can say, higher insolation, right, or higher light, right? And in the winter season, right, the insolation received would be lesser in India, right? So that means the insolation received at a point or at a latitude, right, keeps on changing with change in the season, right, with change in the season, right? So this is the second point, right? So now we know that right now we know that the amount of insolation received decreases from equator towards poles. So please bear this in mind. The amount of insolation received, the amount of insolation received decreases from equator towards the poles, right, and vice versa, right? So it decreases from equator towards poles and it increases from poles towards equator. So that's the point here. Okay. Amount of insolation received decreases from equator towards poles and vice versa. So please bear this in mind. So what is the reason that the amount of insolation received decreases from equator towards the poles, right? So uh, right, let me help you in understanding this with the uh, right, with this diagram, right, or explaining in this way, right? So let's suppose this is the sun, right, and this is the earth, right? So now we can check here that right, so whatever the insolation will be coming from the sun, right, so that insolation will receive the surface of the earth, right? One is this region where the insolation will be received from the sun, this region, this region, right, where the insolation from the sun is received, right? And the next would be, we can say, this region where the insolation is being received from the sun, this region, right? So it may be, we can say, this region, right? So it may be this region also, Okay, so this region also. Okay, so it maybe we can say this region also, right? Maybe this region also, right? So what we are seeing, right? So as we move from equator towards the poles, right? So let me write here for the new students, right? So this is the equator, and here is the North Pole, okay? And here is the South Pole, equator, North Pole, and South Pole. These are the three important things here, right? Okay. So as far as this point is concerned, we know that at the, we can say, equator, right, the rays of the sun at the equator, or we can say around the equator, means between the two tropics, Tropic of Cancer and Tropic of Capricorn, right, the rays of the sun fall almost vertically, right, and when we move beyond the tropics, right, so then the rays of the sun become slanting, right. So it means, what is this, the angle of incidence of sun rays, right, decreases from equator towards poles, right. Okay, so the angle of incidence of sun rays, right, decreases from equator towards the poles. So is this point clear to you, right? And now what is there next, right, with decrease in angle, right, with decrease in angle, right, the amount of insolation, received per unit of area, decreases, right. So this leads to, this leads to this leads to, we can say, right, this leads to, that is the, fall in temperature, and availability of sunlight, availability of sunlight, right, in the regions, beyond tropics, beyond tropics. Okay, so that means, what is there, that if we move towards equator from the, sorry, towards poles from the equator, then with increase in the degree of the latitudes, right, the amount of insolation received would go on falling, right, and that means less energy is received to heat up, so therefore the temperature would be less, right, if we move from equator towards the poles, right. So one point is that, right. So because what is there here, the sun rays are vertical, so that means, right, so one ray has to, you can say, right, one ray has to warm up, or we can say heat up only this much area, right, and here one ray has to warm up or heat up this much area. So it means the amount of insolation received per unit of time decreases, sorry, per unit of space area decreases. So that is why, right, with increase in the degree of latitudes, the amount of insolation falls, received falls, and therefore we can say, right, there is a lesser heat, right, the temperature starts falling over there. One point is that, and the second point is that, the sun rays, right, so which are coming from the sun, right, in this particular region, right, okay, they have to travel lesser distance as compared to the sun rays which are moving from the sun towards this region, right. So this sun ray will have to travel more distance, and this sun ray has to travel lesser distance, right. So if the distance is more, it means the atmosphere in the way will also be more, will also be thick, right? So if the atmosphere is thicker, right, so then what will be there? There will be more loss of energy, more loss of heat, right, on the way, right? So if the more loss of heat is there on the way, then it means in these areas where the sun rays are slanting, where the angle is small, right? So in these areas, the insolation received falls as compared to the areas which are near the equator. So this is the reason, right, that we can say the amount of insolation decreases from, right, equator towards the poles, and hence the temperature decreases. Point is clear to you? Anybody? Any doubt? Please ask. No doubt? Okay, no worries. Okay, so now the next important point, right, which I am going to discuss here, right? So the next important point which I am going to discuss here, that is the, we can say, right, so that is the season. That is the season, right? So now as far as the season is concerned, I can say, okay, so now as far as this season is concerned, right, so season has also an important role, right, in determining the amount of insolation received at a particular place, right? So season, so let me tell you, right, so this is the earth, right, we all know, okay, and we can say that here is the equator, right? Here is the equator. Equator is the 0 degree line, right? Equator is the 0 degree line, right? We all know about it. Okay, so equator is the 0 degree line, which is equator, right? And next to this, let's suppose here falls the Tropic of Cancer, right? Which is, we can say, at 23.5 degree distance from the, right, which is at 23.5 degree distance from the, we can say, this point, right? 23.5 degree north from the equator and 23.5 degrees south from the equator, right, falls the two tropics, right? So this is known as the Tropic of Cancer, right? And this part is known as the Tropic of Capricorn, right? So please bear this in mind. This part is known as the Tropic of Cancer. I'm writing here T of Cancer, right? Means Tropic of Cancer, right? Okay. And this part is known as the, this line, sorry, this line is known as the Tropic of Capricorn, right? So let me write it here again like this, Tropic of Capricorn. Okay, so now what is there, right? So this is the, this blue line is the Tropic of Cancer, this blue line is the Tropic of Capricorn. Okay, so I think I have taught you in some earlier class also that the apparent position of the sun during the day remains at a place in between these two tropics, right? So sun keeps on moving between these two tropics, right? Between these two tropics, right? So because the position of the earth, right, is fixed in such a way that the sun rays, right, the vertical falling of the sun rays is not beyond the tropics in either of the hemisphere, neither in the southern hemisphere nor in northern hemisphere. Okay, so the point is that, right? Okay, so now the point is, what is the point, right? So the point is that we can say this part of the, right, so this This is the one point we can say, right? So the sun is when the sun is on equator, right? So at this point the sun is on equator, right? Please bear this in mind. What is there now? Sun is on equator. Okay, sun is on equator. One point, right? So this happens in March, right? When on 22nd March, 21st March approximately, these are the days, right? This happens in March on this day. Okay, so now what is there? This is the March now. Sun is on the equator, right? And now the sun has started moving towards the, you can say, this northern hemisphere, right? So sun is moving towards the northern hemisphere, means towards the North Pole. Sun is moving there. Okay, sun is moving there. So what is there, right? So in which hemisphere the sun enters, right? In that hemisphere, the what is there? The spring season comes, breaks out, right? Because sun is the source of life. So that is why where the sun will go, right? So the uh, vegetation will bloom there, right? So that's why, right? So this is the position, and this is the outbreak of spring season in the northern hemisphere because sun is moving towards the north, right? So this outbreaks the summer season, right? Summer season in the northern hemisphere, in the northern hemisphere, right? So it means spring is there, summer season is there in the northern hemisphere. It starts now. Okay, so this is there. So now, because the sun is at the equator now, so that is why, right, all the latitudes, right, means a latitude from the northern hemisphere and from the southern hemisphere, right, will be at equal distance from the sun, right? So a latitude, if it is means right, I mean to see, let me clear it to you. If I talk about the 50-degree latitude, right, 50-degree latitude, so 50-degree latitude in northern hemisphere and 50-degree latitude in southern hemisphere will be receiving the same amount of light during the day because sun is on the equator. Okay, equally distant from 50-degree north and 50-degree south latitude. So that is why what is there, right? So in both the right means in a place at 50-degree latitude north or south, north and south, in those both places, insolation received will be the same, right? Though local factors may change the situation, right? We are uh, keeping the local factors constant here for the time being to understand this phenomena. Okay, beta. So now, what is there? At 50-degree north and at 50-degree south latitude, same amount of insolation received. Insolation will be received for the same length of time during the day, right? And that means the days and nights, the length of the days and nights at 50-degree latitude shall be equal, right? In both the hemispheres, in southern hemisphere as well as northern hemisphere at a particular latitude. Okay, so beta, that is why this situation in the northern hemisphere is known as the spring equinox, right? Equinox. First of all, this situation is called the equinox. Equinox, right? Nox means night. Equinox, right? Equi means equal, right? So now, what is there, right? So this is the equinox. Okay, when the days and nights are equal, days are equal to nights, right? So that position is known as the equinox. Is it clear? So now this equinox will be in the northern hemisphere also, and this equinox will be in the southern hemisphere also, because this day will happen in both the hemispheres, right? Okay, so this is the point, right? So if it is in the northern hemisphere, right, at this point of time of the year, this will be known as the summer solstice. Okay, summer solstice, because in northern hemisphere now the summer has started, right? uh, uh, Recoming, we can say, right? Or recounting. Okay, and now what's there in the southern hemisphere, this will be called the winter solstice, because there would be there would be breakout of the winter season in the southern hemisphere, Australia, etc., right? So that is why this is known as the winter solstice. Okay, that's why this is known as the winter solstice. So this is the point, right? This is the point, an important point here, which you need to note, please, right? And then what is there, sun will keep on moving, and by 21st of June the sun will reach here, which is called the Tropic of Cancer in the northern hemisphere, right? The sun will reach here. So now, beta, what is there, right? What is there when the sun is in the northern hemisphere, right? Then what will happen? First of all, let me write it here, that sun on Tropic of Cancer, right? On Tropic of Cancer on June 21st approximately, right? On June 21st. So this point I think is clear to you. Sun on Tropic of Cancer, right? So now when the sun is here, then what is there? The northern hemisphere will receive the maximum amount of insolation on the planet. It means what is there? So in the northern hemisphere, right, a place which is at the this tropics or otherwise, right? So the receipt of light will be for the maximum length of the day, right? So more light will be received. Okay, so more light will be received. This is the one point. Okay, so if more light is received, then what will happen? There would be, right, more heating, right? So there will be higher temperature, more warmth, or higher temperature, we can say, right? So there would be higher temperature in this zone. There would be higher temperature in this zone, right? And now, because this zone remains exposed to the sun for a maximum length of the time, so that is why, right, on this day in the northern hemisphere, right, in this day on the northern hemisphere, right, so there would be, right, there would be the longest day and the shortest night. Longest day and the shortest night. ऐसा क्यों हुई? This is because the northern hemisphere is exposed to the sun, and that is why the northern hemisphere will receive insolation for the maximum length of the time, and the duration of the day would increase, and that of the night would decrease, right? So that's why we used to say here that this is the thing. Okay, so and in the southern hemisphere it will be opposite to this, right? So now in the northern hemisphere there will be the summer season, right? There will be the summer. Okay, so now what is there in the southern hemisphere towards Australia on this particular day, June 21? What will be there? Sun on the Tropic of Cancer. sun is farthest from the southern hemisphere. In southern hemisphere, if we take, there would be higher temperature, and in southern hemisphere there would be lowest temperature because sun वहाँ जा नहीं रहा. In northern hemisphere there would be the longest day and the shortest night, but in the southern hemisphere there will be the there would be the shortest day and the longest night. That would happen there, right? And with this, in the northern hemisphere starts the we can say summer season, and in the southern hemisphere on this day would start the winter season, right? Would start the winter season. Okay, clear point. So this is how the seasons change on the earth. Okay, and similarly the sun will be here at this point. Okay, the sun will be here at this point on, that is the September 22nd September. Sun will be here again on equator, again same positions would happen, right? And then on, we can say this uh, on this 22nd of December, sun would be here. So when the sun is on the Tropic of Cancer, then sun is far away from the India, right? From India, right? And then what would be there? The same conditions would happen, but only reverse. Reverse means, right, only opposite. Opposite means this condition would now happen in the southern hemisphere, right? Would now happen in the southern hemisphere instead of the northern hemisphere. So this is how the seasons change, right? This is how the seasons change, right? So now, as we have studied up to this point, right, as we have studied up to this point, that uh, that the right, that the receipt of light on the surface of the earth, right, so determines the amount, determines the temperature and pressure conditions on the earth, right? Temperature and pressure conditions on the earth. Therefore we can say that right, seasons do change with the uh, this time, right? Right. And now there is the next thing. This is why, because the number one, number one, incoming solar radiation received at all the points of times is not same throughout the year, right? And second, at various latitudes the insolation received in a particular day would not be the same, right? Would not be the same, right? So these are the two important points which are here. So that is why we can say that light is such a component of the environment, right? So which affects the life also, right? Which affects the life, particularly the plant life, which affects that type of vegetation is also affected with that. So we can say this is an important thing, right? So please bear this in mind. Okay, so I think it's okay for you. Now the next point is that as far as the light is concerned, right? So how do plants respond to the light? That is the next question. Or what is the effect of light on the plants, right? So the next question related with this light phenomena, that is how do plants respond to the light? Okay, how do plants response to the right, respond to the light? Okay, plant कैसे respond करते हैं light को? One is this, right? Or we can say, or the effect of light on plants, right? Or the effect of light on plants, we can say, right? Basically there are three important points in this respect to study, that what are the effects of light on the plants. The three important points which I told you, one is, we can say, the quality of life, light coming. Second is the quantity of light coming. right? And third is, I can say, the duration of the light coming, right? Duration of the light coming. Okay, so there are three important points which are important here. 3 points which are important here, right? So one point I would like to say that one point is the quality of light which is coming. Okay, and the second point is the quantity of light that is coming. Quantity of light that is coming. And the third point is the duration of life that is coming. The duration of, sorry, light that is coming. Okay, duration of light that is coming. These are the three important points, right? So as far as the quality of light is concerned, it is determined by the wavelength, right? As far as the quality of light is concerned, it is determined by the wavelength. Okay, it is determined by the wavelength. So one is this, okay, determined by the wavelength, right? So as far as the quantity of light is concerned, right, so it is known as the, we can say, intensity of light. Intensity of light. Light कितनी आती है? Okay, intensity of light. Okay, so this is the second point. This is known as this intensity of light. And now, as far as the duration of light is concerned, right? So this is known as the photo period, right? Photo period. Photo period means that period during which the plants can photosynthesize, right? Do photosynthesis. And the plants can do photosynthesis when there is light. So for what duration light is there, right? So that period is known as the photo period, we can say, right? That is known as the photo period. Okay, so now, as we have discussed earlier, that plants require energy, and energy comes from the light, right? Energy comes from the light. That is the point. Okay? So therefore, light has an important role in the growth of plant, in the survival of plant, in the healthy reproduction by the plants, right? So in all these things, right? In seed germination, right? In flower induction. So in all these things, we can say, right, the light is required to the plants, right? Light is required to the plants, right? So now the point is that, as I have told you, that the plants do photosynthesis, right, in the visible spectrum of light. I have told you earlier, right? And that physical spectrum of light, sorry, visible spectrum of light, that is known as the PAR, photosynthetically active region of the electromagnetic spectrum. That is known as the PAR. Okay, PAR, right? So now the next thing is that we know that photosynthetically active radiation part of the spectrum is that part where the wavelength varies between 400 and 700 nanometers. That also I have told you. All right, 400 and 700 nanometers. Now there are two types of plants. One is the terrestrial plants. Terrestrial plants means the plants which are on the land, right? And second is the aquatic organisms. Aquatic organisms are those which are in the water bodies, in the oceans, in the seas, etc., etc., right? And now the terrestrial plants, right? We can say that, right? When the plants do photosynthesis, whether it is aquatic or it is terrestrial, right? When the plants do photosynthesis, they absorb the blue and red light. This is the Vibgyor, right? Violet to red, right? They absorb this uh, blue, right, and red light. Okay, so in the terrestrial radiation, as far as it is concerned, right, so quality of light does not change much. But when it comes to the aquatic ecosystems, right, in aquatic ecosystems, the water on the surface which is there, that absorbs the blue and red radiation, right? That absorbs the blue and red radiation. So that is why the quality of light matters more in case of the aquatic ecosystems, right? In case of the aquatic ecosystems, okay? Aquatic ecosystems, right? So blue and red light cannot penetrate into the ocean bodies deep. So therefore, right, so a light remains a limiting factor of life in the aquatic ecosystems. So is this point clear about the quality of light? Right? Anybody wants to ask anything, please tell me. Aman, Akshaj, Asika, Amrit, is it clear? Hmm?
Yes,
Or,
sir.
or do you think that I should repeat? Asika, Amrit, tell me. Okay.
Fine, sir.
Okay, Amrit, is it okay?
Yes, sir.
Hmm. So now the next thing is that is the quantity of light. As far as the quantity of light, this is known as the intensity of light also, right? So intensity of light means the amount of light which is received at a particular place, right? So now the point is that amount of light received, right, varies according to the latitude. One point is that, and second is it varies according to the altitude also. Altitude also, right? On the top of a hill, which is 1 kilometer, let's suppose, right, above the surface of the earth, right, above the sea level. So at that point, right, which is at the top of the hill, the atmosphere will be 1 kilometer less thick because the top of the mountain is at 1 kilometer distance from the or 1 kilometer above the that is, we can say, the surface of the earth, sea level, right? So that is why let's suppose, right, let's suppose, let me tell it to you. Let's suppose this is the mountain, right? This is a hill, right? And here lies the sun. Let's suppose, right here lies the sun, right? So if the sun is here, so one ray of, so let's suppose, for if, right, so one is this point and one is this point on the surface of the earth, right? So this is the sea level, this is the above sea level. So now what is there? The light which is coming from the surface at the sea level on the ground, right? So that light has to travel, right? You can say longer through the atmosphere. So if the light has to travel longer through the atmosphere, then it will, right, you can say, lose its intensity on the way, because there will be loss of light on the way, loss of radiation on the way, right? But if it is on the mountainous top, then what is there? The distance is you can say smaller. If the distance is smaller, then what is there? The rays would have to travel lesser distance to reach the surface, means to reach this point on the earth, right? So lesser distance means less loss of energy on the way. If the energy loss is small, less, so then at this point more energy will be received. Okay, so this is how the quantity of light, right, is getting affected by a change in the place. One point is that. And the second thing is that, right, quantity of light or the intensity of light is very much important for the plants, right, for the plants, for certain processes of photosynthesis. One is that certain processes of photosynthesis. One point is that. Second, growth of the plants, right? And next is reproduction in the plants, right? So this is the point. Intensity of light is very much important, right? Because it determines the growth of a plant. Okay, so this is the next point, right? And the next point is that the plants on the basis of the intensity of light can be divided into two main categories, right? So one is the uh, called the shade tolerant plants, and second is the shade intolerant plants, right? So shade tolerant plants are those plants which are less sensitive to the intensity of light. It means these are those plants that can survive even, right, in those areas where the light received is lesser, right, and where the photosynthesis activity is comparatively lesser or not that much aggressive. So this is the we can say shade tolerant species, right? So please bear this in mind. Shade tolerant species are those species, right, which have adapted themselves to survive and grow, right, in conditions with the less amount of insulation, right? So that is the point. Okay. And now the second is, we can say, shade intolerant plants, right? So shade intolerance plants are those plants which cannot compromise with the intensity of light. They need a sufficient intensity of light always, right, for their activities related with the photosynthesis, right? So that is why light affects the environment, light affects the biodiversity, right? Light affects the density of plants, light affects the health of plants, etc., etc. Right? So that is why light is a very important component of the environment, right? So which is important to be noticed here, right? Okay. So now the next point is that is the duration of light, which is called the photo period. Photo period. Okay. So basically, the photo period is a very important concept in the life of the plants, right? Because the duration of light in a plant, right? Duration of light in a plant regulates the phenological processes in plants, right? So it shade intolerance are those plants which cannot survive, grow, or reproduce in the conditions where the intensity of the sunlight is less, or where less sunlight is received. Those are the shade intolerance. Those cannot tolerate the lesser amount of light, right? They cannot photosynthesize properly in that amount of light. So those are called the shade intolerant plants, right? उनको धूप चाहिए, right? उनकी ग्रोथ के लिए, उनकी रिप्रोडक्शन के लिए, राइट, उनकी सर्वाइवल के लिए, मेंटेनेंस के लिए, राइट। और दूसरे जो शेड टॉलरेंट है वो प्लांट है जो कम लाइट में भी सर्वाइव कर सकते हैं, राइट। उनको हम शेड टॉलरेंट प्लांट्स कहते हैं। और आपने शेड इंटॉलरेंस पूछा है, सो ये बता दिया। इज इट क्लियर अमृत नाउ? शेड इंटॉलरेंट क्या होता है? हेलो? Okay, that's clear. Okay, so now we were talking about the duration of the light, which is called the photo period, right? So this photo period, or the duration of the light in plants, regulate the phenological process in plants, right? Regulates the phenological process in plants, right? Let's suppose we know when there is the wheat crop or when there is the maize crop, right, which becomes mature. We know that maize crop becomes mature in this month of August, September, let's suppose, right? So then, according to the conditions of those August, September, right, for so many hours, the light would be required for that plant, right? The light would be required for that plant, right? But let's suppose the light required is for lesser hours or for more hours, right? So then if the availability of lights to the plants reduces or is for a less number of hours, or if it is for more number of hours, both ways the plant will be affected, right? Both ways the plant will be affected. Okay, the plant will be affected, right? So if the plant would have more sunlight, it will do more photosynthesis, it will be more energetic, right? And it would keep on growing, nothing else, right? And if a plant, right, is receiving the less insolation, then it may not be healthy, it may not be able to grow properly, right? It may not bear flowers and fruits properly, right? So that is why the output or the production from the plants that would be affected in that case, right? Affected in that case, right? Because the light जो है, right? So light is such an important factor in the plant life that, as I have told you earlier, that without light, plants cannot flower, right? Blossom. One point is that, right? Fruits would not be possible there, right? Plants use photo, we can say receptors, right? Photoreceptors to sense the photo period. Basically, right? एक प्लांट है, उसको क्या पता चलेगा कि फोटो पीरियड क्या है? Means for how much time the sunlight is received, right? So plants have photoreceptors, natural photoreceptors, right? So with the help of those photoreceptors, the plant determine that this is the photo period, right? And plants adjust accordingly, right? If the photo period becomes longer, right, then the plants speed up their growth, right? And they keep on growing. Sometimes they may not bear the flowers and fruits. So this is the point which I want to tell you so far, right? Okay. So the photoreceptors होते हैं जो, right? So photoreceptor एक तरह का सिग्नल होते हैं, right? जो कि वी कैन से, राइट, प्लांट्स को फोटो पीरियड को सेंस करने में हेल्प करते हैं. सो प्लांट कम्स टू नो दैट this is the period of the photosynthesis. Now for so many hours the light will be receivable to me, right? So if right, so many hours, no? And accordingly you can say the plants may set their working, functioning, etc, etc. So this is the thing that why these things are, we can say, right, important, right? Now we talked about one thing, that is the photoreceptors, right? So please note this, that photoreceptors convert light into the signals. Photoreceptors convert light into the signals, right? And then through the signals, you can say, right, it is sensed, right? So that is the point basically. Okay. So we have discussed about the this what is known as the this light phenomena today, right? Light phenomena today. Yesterday we discussed the soil. Today we have discussed the light phenomena today, right? So I will stop the lecture here today because there are some students who have to go for Rosa opening, right? So the time is there. So I think about 5-7 days of Rosas will be more. And after that, we would be able to extend our class to exact 7 or even 5-7 minutes beyond that also, right? So today we have discussed about this, right? So please bear in mind Please revise this thing, right? We have studied about the light, right? Electromagnetic spectrum, the parts of the electromagnetic spectrum, right? I told you that it is the visible light with the wavelength between 400 and 700 nanometers, right? In which the plants do photosynthesis. Plants sense that light only, do photosynthesis, right? And this spectrum or this part of the spectrum of electromagnetic radiation, right? So that is known as the photosynthetically active radiation, right? So I told you that wavelength increases from left to right on the spectrum and energy increases from right to left on the spectrum. Okay, so I told you that gamma rays are the rays with the very small wavelength, right? Then X-rays have a wavelength longer than the gamma rays. Then comes the UV rays. UV rays have wavelength again longer than the gamma rays, right? Sorry, X-rays. Then comes the visible spectrum, right? So visible spectrum's wavelength is obviously right more than that of the UV rays, right? Then come the infrared radiation, then come the microwave radiation, and then come the radio waves, right? So these are the various orders, right? So then we discussed that light, right? Light is such a phenomena which is affected by the distance of Earth from the sun. One point is that. Second point is the latitude, right? That at which place something is located, right? And next is the season also, right? So these are the various things, right, which determine the availability of light, right? So next thing I told you that plants do photosynthesis in the visible light only, right? In the visible light only. We discussed about that also, right? And the next thing we discussed that seasons also affect the availability of light in the plants, right? We discussed about that also, right? And then we discussed little about that effect of light at plants, quantity of light, quality of light, and duration of light, etc., etc. So we have discussed so many things in today's lecture. So I expect that you will revise your lecture, right, by tomorrow, and tomorrow we will discuss the next topic. Okay. So I'm taking leave for today. Okay. So we'll meet tomorrow. Any question anybody wants to ask, please tell me. Otherwise, it's okay. No question? Hello? Any question of anybody? Hello? Okay, okay, it's okay. Okay, then let me take the leave today. Okay, we'll meet tomorrow. Okay, take care. God bless you.